Hi, my name is Alex Fleischman, and welcome to the video overview for the photoelectric effect demonstration. So a little background. The photoelectric effect describes the ejection of electrons when light is shined upon an object. Electrons ejected in this way are called photoelectrons. Using a computer, go to the website listed below and click the download button. You must have Java installed for the simulation to work. Following the directions in the questions below, run the simulation and answer the corresponding questions. Note, you may use the graphs in the simulation to help you. Alright, so set the battery voltage to 0 volts and the light intensity to 100%. Change the wavelength in the element. For each known element, at which approximate wavelength do the electrons have the greatest energy? Why? Well, for each element, the wavelength at which the element had the greatest energy is approximately 100 nanometers. This is because the energy of the light increases as wavelength decreases. Now set the battery voltage to 0 volts and the element to sodium. Change the light intensity. How does the light intensity relate to the current? Why? Well, light intensity and current are directly proportional, because the more light intense the light source, the more electrons are excited and move. Current is a measure of the flow of electrons, so logically increasing the electron flow by increasing light intensity means that the current increases as light intensity increases. Why do certain materials, when targeted by the same frequency and intensity of light, have different wavelengths at which electrons stop flowing? Well, this is called the threshold frequency, an intrinsic property of each metal. The threshold frequency of a metal is the minimum frequency of incident light below which no photoelectrons are emitted. Now set the intensity to 100% and the light wavelength to about 135 nanometers. Slowly change the battery voltage from 0 volts to 8 volts. How does increasing the voltage affect the current? Why? Well, the current does not change. This is because at 0 volts, the circuit is already flowing at maximum current, so increasing the voltage will not change it. Set the intensity to 100% and the light wavelength to about 135 nanometers. Slowly change the battery voltage from 0 volts to negative 8 volts. How does decreasing the voltage affect the current? Why? The current decreases as voltage decreased. This is because the electrons are attracted to the positive plate, which is also the place from which they are ejected. This attractive force acts in the opposite direction of electron flow, thus decreasing the current.